Howdy, folks, and welcome to your storm chasing forecast show for Saturday, July 11th. I am Gabriel Harbor, and having a lot of fun over there. I'm not quite sure what he's up to, is junior coach Stephen Cross. Stephen, what the heck are you doing right now?
Now, I just really enjoy flipping the planet a little bit, spinning it around, giving it some vorticity. It's a lot of
You
fun.
are an absolute menace. You could not be trusted with godlike powers.
Yeah, I know.
That's a perfect segue to tell all of you folks about the near godlike powers you get when you're using the Weatherfront desktop app or browser app, which we have up on the screen right now. There are so many features, more than you can shake a stick at, actually. We're going to get into some of them a little bit later in the show, but if you want to check that out, link is in the description. So, Stephen, we've got an interesting little setup for today. The tiniest of tornado risks, but there's still a risk, so we're going to talk about it. I'll leave it to you to let us know exactly where we should be starting in our forecast today.
We have a 2% tornado risk here across the mid-Mississippi Valley in far eastern Missouri, southern Illinois, and western Kentucky. It's mainly going to be a damaging wind risk day. Just a typical July setup. Very long outlooks here in July, just with all of that abundant moisture. And there's a very low hail risk. It's mainly, like I said, a wind risk, but isolated tornado risk, and that's because we're going to have a little bit of an MCV. I feel like we've seen that 1,000 times this year in this region. They're very common in this region, these little MCVs, these little areas of spin that are kind of created by the storms themselves, and we'll take a look at that. But first, we'll jump to 500 millibars to take a look at the disturbance that's coming through. So this is our disturbance today. We had a tornado risk across Missouri, very low tornado risk, and that shortwave is going to kind of move off to the east and weaken a little bit. But we should see a slight strengthening in the shortwave, and that's going to be convectively enhanced, which basically means these storms that are going to be ongoing in this region overnight and into the morning hours is actually that rising motion from those storms is actually going to convectively enhance this shortwave and give it a little bit of oomph, a little bit of strength. But as the day goes on, it's going to wane a little bit, and it's a very low end day, so there's really not a lot of potential to begin with, but any potential there may be, it's going to be earlier on because this shortwave is going to weaken with time and push south there, as you see. So I'm looking at that maybe 1 to 4 p.m. time frame for any severe weather and tornado risk.
Yeah, it definitely seems like this is the kind of setup where if you don't get there early, you're probably not going to get anything at all.
Yeah, exactly. The area that I'm honing in on the greatest is going to be this western Kentucky area. Here's our energy helicity index, and that shows the overlap of our wind shear and our instability. And you can see it lights up there in western Kentucky. We'll go ahead and take a sounding here. This is around 3 p.m. And this is where the best environment is going to be. It's going to depend on where those storms set up. You can see a very juicy low-level air mass, lots of 3 Cape, almost 200 joules per kilogram, 83 over 77. That's very juicy. It's obviously July. We're going to have a lot of instability or a lot of low-level instability and low-level moisture. And obviously, you can see our wind profiles are very tiny, typical for July. Very marginally supportive of supercells, 26 knots. That'll support maybe transient supercells, which means we'll get these storms and they'll rotate a little bit, maybe fall apart, rotate a little bit, maybe fall apart, just because they can't quite stay organized. But we have adequate low-level shear for mini supercells, and we've seen this time and time again in this region this year. It's very efficient with these MCV setups. That's going to be the driver for this setup is this MCV. You can see this little area of spin here in southern Illinois. You can see the wind barbs in Missouri here coming out of the west. Over here in Illinois and Indiana, they're coming out of the east. So we have a little bit of spin here in this region. So our MCV there is going to be located kind of east of St. Louis, and it's going to kind of meander southeastward with this convection.
So, is that positioning one of the reasons why you think Western Kentucky has the best shot because it's actually getting those winds as they're starting to back around the bottom portion of the MCV?
Yeah, let's take a look. These winds, for the most part, across the entire risk area are very veered. They don't back very much. I think let's go ahead and take a sounding again with our energy helicity index, see where those best ingredients are setting up. Let's go more towards Poplar Bluff, Missouri. Take a sounding there. And you can see very straight low-level photographs. Thermodynamically, we're kicking just like across much of the risk area there, very juicy, lots of 3 Cape. But those photographs are not very supportive for any tornadoes. But if we go further to the east here into Kentucky, you can see a little bit better curvature here. And that's probably, again, due to just the positioning of the MCV, and perhaps our low-level jet here is a little bit greater. If we take a look, yeah. So our low-level jet is going to kind of be situated here, perhaps on across the borders here of all these states: Missouri, Arkansas, Tennessee, Kentucky. So this is an area that I'm kind of honing in on for maybe an enhancement of that low level jet as it moves into Kentucky and northern Tennessee. Let's take a look at our 3 Cape map. Obviously, this is going to be our driver for any tornadoes since we have such little shear. Enough shear, but just a little bit. Just very typical for mini transient supercells. But our 3 Cape in these setups is always going to be the driver, just with how juicy these low level air masses are. So you can see that 3 Cape across the region, very high values, upwards of 200 joules per kilogram of 3 Cape in these areas. So lots of energy in the low levels to support robust low level updrafts to stretch any sort of spin that we have into tornadoes. And we'll take a look at what the cams have to say. So this is the HRRR run. Here's 0Z. So we're going to have, obviously, like I said, that all that convection kind of enhancing that short wave as it progresses throughout the day. I don't think this convection is going to be too much of an issue. If we take a look again at our Cape, it's obviously going to decrease our Cape a little bit, but that we should go straight back up into the about 1,000 joules per kilogram of Cape there. It might be a little bit locally higher just because this is the HRRR, but that should be plenty. Again, it's very low level instability driven. And you can see all of these updrafts going up. And this is closer to the 3 to 7 p.m. time frame in Western Kentucky. So anywhere between maybe 2 and 7 p.m. is going to be our main time frame to watch here across the risk area. So you can see we have all this convection, and it's just going to be a kind of wait and see, pick out the most robust looking storm in this area. I'd set up maybe near Vienna, Paducah, perhaps a little further west if you'd like. But yeah, these are notably difficult to chase because you get a lot of these tiny little showers and then they start to rotate, and you can't really, you got to be close to them and then kind of dart after them. It's not like super sub go in the distance and you have an hour to get to it. These happen rather quickly. That's why I busted my chase out here in a similar setup with the Mount Vernon or Dix EF3 on, I think, June 21st. It just popped up so quickly. So you're going to kind of have to pounce on these very quickly because they're going to start spinning rather quickly with all that low level juice.
And before we go any further, I want to let all of you know about our channel membership here on YouTube. We got 2 different tiers. The first one gets you bonus videos every single week. The second tier is the one that really unlocks the most value. It's called Chaser Academy. I think it's listed as tier 2 when you check out the channel membership. Link is just below this video. And you will actually get access to our weekly live streamed group coaching sessions. Those are great. We take questions. We have full presentations. We have different coaches every single week. And you also get access to a special role on Discord. If Discord's your thing, you're going to get our Coach Q&A channel where people like Steven are in there around the clock answering questions. Anything that comes up, if you're out chasing, if you're in a classroom, whatever the case may be, our coaches are there to help you out. So check that out at the link below. Just click the join button. And now back to Steven, who I believe wants to show us a little something over on StormNet. It is the tool that all the chasers have been talking about these days.
Yep. So we'll take a look. I don't expect anything too crazy with these probabilities. Again, it's a low end risk, mainly a damaging wind risk. So we'll take a look at those winds really quickly, the wind risk. And yeah, I think the wind risk is going to be highest down here. I wouldn't be surprised to see a little bit of an upgrade, maybe into northeast Arkansas and western Tennessee here near Memphis. I think we're going to have kind of a propagating cluster here as it moves southward into these regions. I think that's going to be the greatest damaging wind risk. But the highest tornado risk, still low, but still a tornado risk up here in, of course, our risk areas that we talked about, mainly southern Illinois and western Kentucky. You can see we have some probabilities here. Let's see what StormNet is saying. So right on line with the SPC, 2 to 3% here in this region. So not very high, but notable. Here's our NATOcast. Again, that Western Kentucky region that I was highlighting is being highlighted on NATOcast there with a 3% risk. I think that's going to be the greatest area between, say, we'll call it 3 to 6 p.m. across this region. So yeah, good to see that NATOcast, StormNet, and my forecast are all online here for this area for the greatest MCV tornado threat.
Now, you were talking about the wind risk when you had StormNet up, and that is something that came up in a lot of the SPC talk, a lot of the area forecast discussions were the inverted V sounding. So if you could maybe take a moment, Steven, let people know what does that mean when there's an inverted V sounding, and then also how does that correlate with an increased wind risk?
Yeah. So inverted V soundings are basically when you have a very big spread between your temperature between your surface temperature and your surface dew point. You can see across Arkansas and Tennessee, we're going to have very hot temperatures here in the mid 90s. And when we look at our dew points, that's like a 20 to almost 30-degree difference in our dew points and our temperatures. And if we take a sounding ahead of these storms that are going to be propagating southward here, we'll take one kind of here near Forest City ahead of this line. You can see what those spreads do is we get this big space here between the temperature and the dew point, 93/71. That creates these inverted V's. It looks like an upside down V, an inverted V. And when you get this moisture aloft, you basically get this rain. And as the rain falls, it evaporates because there's so much dry air here at the surface. The rain evaporates, and basically the momentum, it hits the ground and spreads out, and you get these damaging winds. So we call those microbursts. So we can get some microbursts here across this mainly northeast Arkansas and north or central eastern Arkansas around Memphis, the Memphis area. I really like using this HRRR wind gusts. I find this to be pretty accurate, not exactly on the storm placement, but perhaps the intensity of the winds. That's what I've noticed lately as I've been using this. And we could get, it's putting out 80-mile-an-hour gusts. I would not be surprised with those profiles. I think it's going to be that perhaps up to 70-mile-an-hour range here with most of the storms, but we could see some locally higher gusts with these storms.
And Stephen, with those inverted V profiles and that evaporation, is that because evaporation is a cooling process, and so as that air evaporates, it cools, colder air is heavier than warmer air, so it just gains more momentum as it's going down to the surface until eventually it's gained so much momentum that, like you said, it just fans out and explodes in all directions?
Yeah, exactly.
Stephen, I also wanted to get your opinion on potential flooding risk for today, because I noticed also a lot of the area forecast discussion seemed extremely concerned about the amount of saturation that was already present on the ground, and how a lot of these storms that had high precipitable water values might add to the problems that they've already been experiencing across the main threat region.
I'll show you really quick our soil saturation. This is a very cool tool with Weatherfront. It's one of my favorites, honestly. I haven't found it really elsewhere on any other radar apps. You can see these soil saturations, especially here in Missouri. This is where we had our flash flood emergency the other day, I think yesterday, and we'll go back in time a little bit. And you can see these soil saturations here in eastern Missouri are approaching 90%. That's very high. That means like the soil is 90% saturated with water because we had so much rainfall here. You can see all of this rainfall we had in this region. There's no surprise that we had a flash flood emergency, and these soils are just so saturated. So when you get rain in this area, the soil is already holding so much water, it can't hold anymore, and it has no place to go but downhill. And that's why you get so much flooding when these soils are so saturated.
I know one other thing that I've heard a lot of people talk about in regards to flash flooding events is that they're so localized that it's really difficult to predict exactly where they're going to occur ahead of time, which is why you might see these broad risk areas, and you really have to have your head on a swivel. You have to have your emergency alerts turned on. And I know this firsthand from being out storm chasing. We're so focused on the convective aspect of things, or rather the severe rotating convective aspect of things, that a lot of times those flash flooding warnings, they can sneak up on you and you don't even realize maybe that you're in a bad spot. So it's really important to keep your situational awareness when you have something going on like this.
Yeah, it happens very quickly. Here's another very cool product, and I'm still learning how to use all these because I've never used them in the past until I got Weatherfront. It's very cool. So this is our stream flow. It basically shows all of these rivers here and how much water is flowing through them. And you can see in this region here, we're in all of these pinks across our risk area. So the rivers are holding a lot of water. This is 6,000 cubic meters of water per second going through these rivers here, is I believe what this product is showing. So there's a lot of water out here, and that's going to be something to watch even across just our main risk area here. You can see the soil saturations across that southern Illinois, far southeast Missouri into western Kentucky. These soil saturations are very high in the 70%, and upwards of 70% in some regions. So watch out for flash flooding if you're chasing. And like Gabe said, it's a very localized kind of thing. It can really catch you off guard. And we'll look at our PWAT values. We'll take a sounding. So here's a sounding in the southern Illinois region. You can see upwards of 2 inches of PWAT there. That's a lot of water in the atmosphere. So flooding risk is going to be rather elevated across these regions. So just be careful if you're chasing.
As promised, it is time for everyone's favorite portion of the show, even though this is the first time we've ever talked about it. Steven, tell me what is going on out there in the great state of Arizona, maybe a little bit of New Mexico with the monsoon.
If I could be chasing anywhere in the country, it would be here near the Tucson, Southern Arizona area. I don't care for any of that MCV stuff. I would chase this monsoon. It looks like a lot of fun. And this is my first time ever forecasting a monsoon setup because I don't live out here. I don't really pay attention to it. I don't forecast it much. So this is a learning process. I had to phone a friend. I had to phone Trey to kind of give me the rundown on what's going on here. But I'm slowly learning, so we'll go over that. Our main driver is this low end wind risk. There's no hail risk, but I know there may be isolated instances of large hail. But with these monsoon risks, you're mainly just going to get wind because your cloud bases are so high, like we talked about earlier, those inverted V's. So our main driver across the southern Arizona and New Mexico area is just this wind risk. We don't have any other risk for tornadoes or hail. I wouldn't be surprised to maybe see a 5% hail. I know there may be some isolated instances of large hail that Trey talked about, but otherwise it's mainly just going to be a wind risk, which is what you get with these monsoon setups because your temperatures are so hot here in Arizona. Your dew points are generally on the lower side. You get, like we said, inverted V profiles, very high clouds. You get evaporative cooling, and you get a lot of downdrafts here and dust storms. But I wouldn't be surprised to maybe see a little upgrade on the hail risk. But yeah, it's a very low end risk, but that's not why chasers chase. They don't chase for the wind out here usually. They chase for the scenery and the lightning and the dust storms out here. So we'll go over that really quickly. So we should have an upper high here across the Four Corners and Great Basin region, and that will promote this easterly flow into Arizona, this enhanced easterly mid-level flow here across the Tucson area and southeastward. And that's going to be our main area of interest for our storms. All right. And let me actually move on over to a different site. This is the site that Trey recommended. So this is a University of Arizona's in-house WRF model, and it's run using GFS schemes and the HRRR schemes. Trey mentions that it significantly outperforms all of our operational cams that we typically use for severe weather forecasting. So if you're chasing the monsoon, I would highly recommend just using this, weighing all of your forecasts, most of your forecasts into this site. Trey seems to find it very helpful. So we should have a nice pocket of moisture here across our area of interest. Mid to upper 50s dews, perhaps creeping into the low 60s in some areas. But we'll take a look at our temperatures, and very hot. It's Arizona. We're going to perhaps reach into the hundreds in this area. So that's going to create very high cloud bases. But what that will create, those hot temperatures, is going to create very steep low-level lapse rates. Let me take a sounding there. So here's a sounding here across that Tucson area and southeastward. You can see very steep low-level lapse rates approaching 10 degrees Celsius per kilometer. Obviously, those temperatures are so hot that the latent heat is released very quickly, and we get these very steep low-level lapse rates with these very high cloud bases. And this moisture aloft with that dry air at the surface should promote damaging downburst winds, which is going to be our main risk. But that'll also probably produce some pretty impressive bolts. And that's, again, why a lot of people chase out here is you get these very tall clouds with very tall lightning bolts. And when those sunset colors come in, I'll show you some pictures. When you look up monsoon, it is just an absolute dream. I don't know why anybody would be opposed to chasing this unless you're just purely a tornado person. This looks fantastic. It's my dream to go out there and chase. I'm going to maybe hope to get out there in August. Look at these. This is just beautiful. People chase out there for the scenery because look at that. That is insane. And when you get lightning bolts out here with the sunset colors and the mountains and the cactus and the sand, it is absolutely stunning. So there's no question as to why Trey is out there. I know he grew up there and started chasing out there, but it looks like a whole lot of fun. And when you get these, it's so dry out there in Arizona. When you get these downbursts with these storms, you actually, it kicks up a whole bunch of dust, and you get a whole bunch of dust storms down there with these downbursts. So that is another aspect that we could see out there with these downbursts. So we'll take a look at the future radar. So like I said, nice pocket of instability here, about 1,000 joules per kilogram. It'll start to wane as we approach sunset, but still should be plenty. So here's our future radar. So you can see around 22Z, we start to fill in with some convection here as we approach sunset. In the southern Arizona region, we get a lot of convection here, just south of Tucson, south of the highway there. So that's going to be my main area of interest for storms there. Here's our lightning cloud to ground flash count map. I think this is pretty neat. You can see this accumulated lightning here across southern Arizona. So like I said, that southern Arizona region south of Tucson is going to be our main area of interest for those monsoonal storms.
Remember to check out those links in the description below, and then watch another video.